Hi everyone, Jonathan here. Hope you guys are doing great. Now, I have been trying to explore some open source projects that I've been keeping my eyes on and try to build little cool things with them, some of which I'm going to even be making videos about here. But one of those frameworks is Lightstar and another one is Django Bolt, which I actually made a video about. And these have one thing in common. Instead of using a library like Pydantic, they are all using a lightweight library called Messagespec. So what is Messagespec? Messagespec is a lightweight data validation or serialization library that also does things you would find in the Python standard library. Things like reading JSON or decoding JSON are found in that library. But it not only does JSON, it also supports formats like TOML and YAML and also MessagePack. So in this video, I'm going to be giving you a brief tour of this library so that you can find it useful or use it in your projects and maybe even run some benchmarks to show you how it performs compared to, let's say, the inbuilt JSON module. So without wasting your time, let us get into the code. So everything I'm going to be talking about is going to be found at the documentation, which I'm going to leave a link for in the description of this video. MessagePack is a fast validation and serialization library that also does the same things like your JSON Python module. It also has support for JSON, MessagePack, YAML, and TOML. It is a high performance encoder or decoder. It has like support for these very many Python types. Now let's go ahead and just dig in and install the library, set up a project and try to play around with it. Now what I've done is to create my project folder in here. It's found in my desktop and I have two files in here. One is called benchmark.py and another one is called products.py. For now, I'll only show you the contents of products.py. Products.py just basically has some product data. This is data that we're going to be using as demo data for demonstrating the encoding versus the decoding. And then benchmark.py on the other hand is a file that I'll open up later. So to start, let's go ahead and install Messagespec. I'll do that by saying uv add Messagespec. And basically doing that will install Messagespec with only support for a few data formats. But if you need to add support for, let's say, TOML and YAML, then we have to specify that by installing Messagespec with TOML and YAML. So if I go ahead and run that, I have to first of all create a new UV project using UV init, and then I run that command to install the necessary dependencies for this project. So once I'm done, then let us go in here. We have our UV project set up. We have a main.py file as well as the other files we had. So what I'm going to do is to import Messagespec. Now VS Code sometimes tweaks and fails to make the auto completions work well. So I'm going to have to investigate that. I see my auto completions are working well. Now the beauty about Messagespec is that if you want to, let's say, access JSON specific functions, you can do that via a sub module named after the format. Same for YAML, so you can say messagespec.yaml, and then the same thing for TOML, so we can say messagespec.toml and messagespec.MessagePack. So that's basically how you access the different submodules that can help you get access to functionality for decoding, encoding, and performing actions on those different formats. Now, another thing that's interesting is that all these are implemented to be very similar. So for example, if we headed over to the code of our library Messagespec, we can now see these modules, YAML, TOML, we can see JSON, MessagePack, but there's one thing that's common among them. They implement functions, and those functions are implemented to be very similar. For example, the decoder class is the decoder class, and the encode function is the encode function. So if we need to do encoding in JSON, we can do messagespec.json.encode. If we want to do it in YAML, we can do that. So basically they have this very uniform format or uniform way to access functions that is very easy, that makes it very uniform across all the data formats you may want to work with. Another interesting thing that this library has is that rather than having implementations of everything, they basically have just this core shared object file. So this is a binary file, but at runtime it gives all the C specific things or the implementations of these functions to all the Python files right here. So if we go to, let's say, MessageSpec.json, then we can see this just importing this from .core, but there is no specific Python module called core. So these are being got from the C side of things. So this is basically something that is very interesting. And if we can go to the documentation or the GitHub repository, that shared object is generated from core.c. So all those files and the types like JSON decode or decoder, they are found inside this C core file or the core C file. So let's try to look into JSON decode, or let's say decoder. I see something wrong here, so let me just go back. It basically just contains a bunch of C stuff, but then in here is where most of the implementations for our functions are implemented. So that's basically something that I needed to show. Now, the first task we're going to carry out is one of trying to encode data from our Python objects into our JSON or our TOML or YAML or MessagePack. To do that, I have already some data that is found in a file called products.py, and that's exactly what we're going to be reading from. So I'll begin by importing it. I'll say from products, we're going to import the data, and then if I go ahead and print data, this will just basically print everything we have. So if I go ahead and say uv run main.py, we shall get all our data as a dictionary. If I want to encode this into JSON, then I'll have to do that via MessageSpec.json.encode. So that's the function. I made a mistake right here. Now, this function takes in the object, which can be any object. So this is basically a valid Python object. So I'll provide our data. Now, I'm going to name this encoded, and I'll also create a variable called encoded, and that will have our encoded data here. So I'll provide our data. If I print this, this is going to be different from what we had initially because these are going to be bytes. So these bytes can be further worked with. So we can do this by maybe passing them on to some way in which you may consume them as bytes, or we can even write them to a file. So let's try to write this to a file. I can create a context manager right here with the open function, and I can create a file called data.json. So what this is going to be is a file. So we want to write to it, and we want to write bytes to it. So open, if we open and call open with the mode of write bytes, we are going to get a buffered writer object that we can then write some bytes to. So I'll get this as a file object, and then I'll indent this to be inside in here. Maybe I can get rid of the print statement right here. So if I say json.encode, then I can finally call file.write, and then file.write will take in the encoded data, all the bytes that we need to write to this file. Now, when I do this and run the file, this time we shall see a new file created, and this is going to be our data.json. So this JSON file has been generated from the data that we had inside our products.py from Python into JSON. We can perform this action using the Python standard library. and that is with the JSON module. I'm going to be doing that and also showing you how this is slower compared to MessageSpec when it comes to performance. So let's go back to our main.py, and I'm going to repeat the same process, but I'm going to instead use the JSON module inside the Python standard library. What we can do is to go ahead and say with open, let me just call this data2.json, and instead of getting this opening this file with write and then bytes, I'll just call it with the write mode, and then we shall get the file. So basically what we have is an object. This is going to be a text IO wrapper, but this will be a buffered writer object. So there are two different objects that you can get even with the same open call. So this provides a text IO wrapper, this one provides a buffered writer. Now we can just simply call json.dumps or json.dump, and this will take in the object that we want to dump. In this case, that's going to be the data as well as our file or our support write object or the text IO wrapper here. So in this case, we shall provide file. I'm going to comment out this temporality, and if I go and run here, we shall now basically come to see that our data2.json is the same file with the same content of the JSON we have. So in actual terms, this can not be seen as slow, but it will be slow when it comes to larger files. To show a simple benchmark or run a simple benchmark, I have created a file called benchmark.py that basically contains code for measuring how fast MessageSpec is compared to JSON as a way of encoding data. So I have two functions. One is called get average encode time, and the other one is called get average decode time. So how these functions work is I provide data. In this case, that's going to be our product data, and then that data is going to be some data that is of valid type that we can easily turn into JSON or serialize into JSON. And then I have a lib parameter right here, which is going to specify that we're using either the JSON standard library module or MessageSpec to encode the data. Then we have a number of iterations, because for us to get an accurate fill, we then have to simulate this using many iterations. For this case, I am running a for loop with a range of the iterations we provide, which are 100 by default, and then we provide a start time using times performance count. And now this is a very important function that you need to call in case you are running benchmarks to provide much more accurate results for that time. Now, if we provide our lib as JSON, then we shall use json.dumps. If we provide our lib as MessageSpec, then we shall provide MessageSpec.encode. And I feel this is an accurate way in which you can measure the time it takes to encode data using either of these libraries. So how am I calling this here? When it comes to encoding, I just simply get the average time from MessageSpec, and then I format this to milliseconds. So I'm also doing some conversion here of the times to make this milliseconds, since there are 1,000 milliseconds or microseconds. I think these are microseconds in 1 second. So I have to multiply the seconds to 1,000 to convert them to microseconds. Now, if I run this benchmark.py right here, you'll now see that compared to the JSON standard library module, MessageSpec is way much faster when it comes to the encoding part. Now, this is a very simple data set, so you can't really see it, but when it comes to, let's say, encoding a very large chunk of data from a Python object to JSON, still MessageSpec will be much faster, and this demo can basically show that. Now, another thing we can do is to go ahead and decode data. Now, decoding data is the difference of encoding data. What we've so far done is to get a Python object, like the list of dictionaries or the dictionary we have, and then converted it to JSON. But we can also perform the same actions for different data formats. For example, if I showed you how we can perform the same action for, let's say, our YAML, transform the Python data into YAML, I can convert this by saying that instead of JSON, we're going to have data.yaml. Now I just have to come here and say messagespec.yaml.encode. And if I run this file, so this time we're going to have run main.py. I will come right in here and then I'll see a YAML file here. So this is going to be YAML data. So it will encode this from JSON, from actually Python to YAML. We can do the same thing for TOML. So let me try to change this. If I come right in here and change from TOML, since it's the same way of doing things, same functions we are calling, this time I'll have my TOML file created, which is data.toml. And this is how it will look like. If I want to transform this to, let's say, MessagePack, so I've done JSON, I've done TOML, YAML, I can say MessagePack. I don't know if this is the right way to name a MessagePack file. So if I say MessagePack.encode and run again, this time we shall get a MessagePack file or a file with MessagePack. Now, one thing to know about MessagePack is that the data will be like in binary format, just like you see right here. So that's basically how the MessagePack data will look like. So that's basically how you perform simple encoding from Python native types or other types supported to JSON or to YAML or TOML. Now let's look at the opposite, which is decoding. Now when decoding, what we're actually doing is to transform from the data format from, let's say, TOML to Python. It's basically the opposite of the serializing we've been doing. So what you're going to do is to now call the decode function. To call this, let's try an example where we have some encoded data, and this is going to be encoded in JSON. So in this case, we can say messagepack.json.encode, and then this is going to be our data, and to turn it to our decoded data, so this is going to be the Python dictionary or the same structure we have in our products.py here is what we expect to be returned from our bytes. So in this case, we shall say messagespec.json.decode, and this will now take in the buffer. So the buffer is the bytes we shall get from encoded data. So that encoded data is what we pass into the decode, and we shall get our data. So if I print this out, we shall have that return our dictionary, just like you see right here. Now this is very similar for all the other formats like MessagePack or JSON or YAML or TOML. Now one thing I wanted to do is to run the benchmark for decoding. With the same data, if I take you back to my benchmark.py, I'll go to a function called the get average decode time. Now this basically does the same, but at first it first of all encodes the data just like we have done, and it basically will take in JSON. If it takes in JSON, it will use the JSON dumps function, which also just basically gets to get an object, which is our Python object, transform it into a JSON string. And after doing that, we then use that string to convert it back to our Python. So that's the loads function. It will deserialize it from the string, which is a JSON string or bytes, into a Python object. Same thing for the decode here. We get our string or buffer, and then you transform it into a Python object. So let's try to run these benchmarks, these two benchmarks for encoding and decoding. If I take you back here and run uv run benchmark.py, we shall now see still Messagespec is way faster when it comes to encoding and decoding to the inbuilt JSON library. Now this simple script is going to be made available on GitHub if you're interested in maybe improving it or sharing some ideas about how we could benchmark, maybe add benchmarks for Pydantic as well and stuff like that. But this is a simple script I came up with to show how fast Messagespec can be compared to the inbuilt way of validating JSON or reading JSON. Now, when it comes to decoding, there's also something else that is called type decoding. So type decoding is where we have a model that can validate what we are trying to decode from a format like JSON into our Python type, like a dictionary or the structure we have right in here. The way we achieve that is through the use of MessageSpec structs. So MessageSpec structs can be thought of as Pydantic models. They are what Pydantic-based models are in Pydantic. They're basically classes that you define with all the fields, and then you can add all these necessary properties to those fields that will add that validation of the types as well as other constraints you may set up. So to start, let's go to our main.py and create a structure for our data. We shall keep this decoding logic right here. If I come to our products, our goal is now to decode this, but use some sort of validation to check for invalid fields in the data we are trying to decode. So I'm going to create this model. So our products basically have this structure where we have at the top a products key, and then we have a list of products. These products are also going to have name, category, and brand. So these are sub fields. So we have a brand and category can also be their own nested models. So to start, I'm going to create a Pydantic struct. To do that, I'm going to create a class, and this class is going to be called the product list class. So think of this as the entire JSON payload we have right here with the entire container in which our list of products is found. And this is going to be a MessageSpec struct. So to access MessageSpec struct, we're going to go to MessageSpec.struct. I'm going to pass this for now. Let's look into the implementation of a struct. So a struct is going to have the fields and the config. And when you look into the Danda init, it will just basically have args and keyword args, and in here we shall have a tag field, omit field, forbid unknown fields. So we can rename fields frozen, equal, keyword only, dict, and so on. So let us just basically create a field. So we have products. Now, we also have brands and categories. So these can also be thought of as their own fields. So instead of having this as a dictionary of a string, we can create a type or a MessageSpec struct that is going to stand for the category. Now we're going to repeat this for our brand. So I'll come right here and add our brand. So this is our MessageSpec structs. Now these MessageSpec structs are interesting in a way that they seem very similar to a normal class with type hints, or let's say how you define fields on a data class. There isn't a lot of setup, there isn't a lot of things to make the classes verbose. You just basically have a class and it inherits from MessageSpec.struct, and then you have your field with the required type hint. So once that is done, we can now go ahead and validate our decoding. To validate our decoding or to perform some type of typed decoding, we can do type equals, and then we provide the type. So in this case, we provide product list because our data that we're trying to decode is in the format of this exact format we have right in here. So if there's a field that actually fails to match what we have as our model right here, MessageSpack has to throw a validation error. So let us try to do that. Now I'm going to come up here and I'll run uv run main.py. And now we see a validation error. So the first validation error we are seeing, it's saying expected integer got string, and that is at product 0 price. So it seems like I have an error in my products. If I go to the first product, I have this in strings. So if we change this to become an integer, it will match our models. So if we go right here, we now see our data being decoded, but this time we now get a structure that is in the form of our Pydantic structs. So that's basically how you perform your typed decoding. Now another thing that we can do is if we go back here and change this to quotes, of course we're going to get back to that validation error we had at first. But if you have used Pydantic, you will know that Pydantic can basically just know that this is a figure and therefore pass the validation. But for MessageSpack, it will throw a validation error. And the reason as to why it does this is because it has two modes. You have that strict mode, which is the default mode for decoding, and the lax mode, which can allow you to basically just cast, or let's say make the type be what it actually is. For example, this right here is an integer, it's just in quotes. If we were to validate this data with Pydantic, it would pass, but with MessageSpack it won't pass. It will show a validation error. So how do we disable that? Let's go back to our main.py right here, and where we are decoding, we're going to add one more argument, and that's going to be strict equals, and in this case we shall specify strict to be equal to false. Once we do this, then our validation will pass. So that means even if we have an integer that is in quotes, it will be seen as an integer by MessageSpack, or our validation will pass. Now MessageSpack structs are MessageSpack's most important feature, as it allows you to be in position to perform the definition of structured data, just like the products we've created so far. Now, we can perform a lot of actions similar to how we do it in Pydantic. For example, we can go ahead and create some products and some categories which are not part of our list. So how do we do that? It's just basically creating instances of our Pydantic, I'm calling them Pydantic, but they are MessageSpack structs. So let me comment this and then create some products and categories. So let's start by creating a category. Now, to create a category, all we have to do is to create an instance of our category class. That is a MessageSpack struct we've created. And I'm going to give this a name. So let me just say this is going to be a category of laptops. But I can even just maybe make this be specific by just giving them a name. So this is going to be our laptops category. I'm going to create another category and I'll call this, let's say, the smartphone category. So the name for this category is going to be the smartphones category, and then we'll have, now once I've created this, then I'll go ahead and create some products that are under the following categories. But let me also create some brands. The novel being a brand. So these are all objects, but they are representing the different brands and different categories. Now let us go ahead and create some products. So that's basically how we've defined the product. To access the different fields, all we have to do is to just, let's say, print, then get the object dot the name of the field. So let's say I want to get the product name. That will give us the product name. And if I run this, we'll now see that will return our product name, just like you see right there. If we want to access any other attribute, you just have to say dot and then the name of the attribute. Let us go ahead and create another item. I'm going to go down here. So those are two MessageSpec struct objects. Now we can also access its name by printing ThinkPad Lenovo ThinkPad.name, and that will actually give us the name of the product. So we have Lenovo ThinkPad. We can perform all things, including checking for the equality of these objects. We can say print iPhone 17 is equal to Lenovo ThinkPad. And of course, these are not equal objects, so we can get false for that. We can perform quite a lot of interesting things here. Now, beyond just defining these fields, we can also perform different interesting things at the struct level. For example, a name or a field can have a default value. And how we do that is by basically providing, for example, let's say for those products that do not have a definition, we can provide a default as none or a default as an empty string. And we can also basically specify that with type hints by doing none, just like that. But since we do not have the right order, because this will create our class as one that has keyword only arguments or keyword only parameters coming before those that are not keywords, then we'll have to change the order so that these appear at the very bottom of the class definition. And I'm going to be showing you a way we can go around that. But for now, if let's say we have a product that doesn't have a description, let me change the description of product number 1. So I'll get rid of the entire description. When you go back to our main.py and run this file or run the code for, let's say, let me actually do it for these products. So I will just go back here and do what we did, come back to main.py and remove the description for, let's say, the iPhone 17. So if I just print print iPhone 17, what is going to happen is that we shall now have none as the description of iPhone 17. So this will be our product and this description will be none. So that will mean that we can have a default value none for that field. We can also set dynamic values for fields, and this is very similar to how you do it in data classes and in Pydantic. MessageSpec provides a field function that has the default factory argument or the default factory parameter, and this takes in a callable that can generate a new value. For example, let's say we wanted to set an ID field. This is not defined on our data, but we can set, of course, a field for it. So this can be some sort of UUID.UUID, and then we can have MessageSpec.field. So this is a function, and when we look at this definition, we have default. This can be the default value, and we have default factory that will be a function that can provide a value, and this is a function that doesn't have to have a parameter. So in this case, what we can do is to first of all import what is not imported. We shall import UUID, and then we shall also go ahead and provide a default factory, and default factory in this case will be UUID.UUID4. So what this will do is every time we create an instance of our product, a new ID will be created and given to that product instance. Now, of course, this is a keyword only argument, so we have to fix the order and put it at the very bottom of our class definition after all the non-keyword arguments. I'm going to be showing you how to fix that. So in this case, if we let's say run our code, we shall now see all the other fields as well as the ID created for us dynamically by MessageSpec. So that's something that is important for fields where you want to have values generated. Another important thing is we can keep to our order of, let's say, the field definitions with keyword arguments appearing first and then non-keyword arguments. How are we going to do that? Let me begin by first of all explaining what happens every time we create an object. So every class defines a danda init method, and that danda init method is one that's going to be responsible for helping you create instances of that class or objects of that class or type. Now these fields are always going to be ordered in a way that keyword arguments are defined after non-keyword arguments. How to fix that is by providing a keyword only argument in the definition of your danda init. So by specifying keyword only equals true, you are letting the class be one in which all the parameters of the danda init are defined as keyword only parameters. So all these fields will now be seen as keyword arguments or keyword parameters, and therefore the error will go away. So that means you can have fields like the ID that are keyword arguments appearing first before those that are not, or those without default values. So let's go ahead and run this. If we try to run this again, we now see that we do not experience any errors. There is so much to Pydantic class. I'm actually calling these Pydantic classes, but they are MessageSpec structs. If a struct type defines a post init self method, this will be called at the end of the generated init method. It has the same semantics as data classes methods of the same name, and its method may be useful for adding additional logic to the init function. So in addition to the init, post init hook is called when decoding a struct type or converting the struct type. So just like you see right in here, we define the MessageSpec struct, and if there's any sort of validation that needs to be done, we can do that in the post init method. So let's try that. I can go right here and say post init, and then this will be self. So in this case, let's say if price is less than 0 or less than or equal to 0, which is actually self.price less than 0 on an object, then we will raise a value error. This is very similar to what we actually have in that example. So if I say price should be greater than 0, so that's some sort of validation we are adding here. If I go to my terminal right here and run uv main.py, of course we don't have a product that has a price that's less than 10. So let's try to provide the price as 0 here. We now see our error being raised. That's telling us that our price is less than 0, or our price should be greater than 0. So that's basically everything that I can show about MessageSpec for now. If you have enjoyed this video and would like to see more about MessageSpec, leave me some comments down in the description. Please help me boost these videos by clicking the like button, and also click the subscribe button if you're new here. This is the content that I am trying to make, and if you find this content useful, then please let me know what I can do. Also, I know and understand that many of us are now coding with AI, and I'm planning to make some videos about simple ways you can program with AI. I am not the vibe coding type. I have tried it out, and honestly speaking, it just bores the hell out of me, and I'm not falling for the hype of that I will be replaced if I do not vibe code. So I'll make videos about AI if that's what you're interested in. Leave me a comment telling me how you feel about that, and see you in the next one, guys. Have a great day, and bye.